Lecture 18, Q&A. So the question was, if you have an account class like this, is deposit a class attribute? And technically it is, but that's because it's a very special kind of class attribute, it is what's called a method. So it would be rare for someone to call this a class attribute, even though that is technically true. What it really is a method, which means that the only way that it usually gets used is by having an instance of an account and then depositing into that some particular amount, at which point self gets filled in automatically. And the other part of the question was, what are the instance attributes in this example? There are two. They are holder and balance. You know something's an instance attribute if it's assigned to an instance. And self always refers to an instance of account inside of the body of a class that's about an accounts. Sure. So the question is, what's a bound method and how is it used? Well, if I have an account, it's mine. Normally I would deposit into it like this. This expression here actually builds something. We could give it a name if we want. This thing is called a bound method. And what's a method about it? Well, it's a function defined within a class. And what's bound about it is that the self argument's already filled in. So this is not just depositing in general. F is depositing into A. John's account, which is called A in this example, is already bound to self, meaning what we're left with in this bound method is a function that only takes one argument. So that's what a bound method is. It's a method. A method is some function that's defined within a class that has already had itself filled in.
Right. So to Sandra's question in the chat, they are different. And it just, as John was just saying, in the bound method, you've already filled in one of the parameters. What is the object you're sending in? It's still doing the same thing, of course. It just sort of, you've delayed the evaluation a little bit, right? You've taken like one step in the evaluation by binding self.
Yeah, and I guess a follow-up question might be, what's a method that's not bound? You can actually access that. It's a little bit more rare, but there are reasons why you might want to do it. If we access the deposit method directly from the account class, notice the difference. We had an instance here. Here, we don't have any particular account that we're talking about. We're just talking about accounts in general. What does it mean to deposit? Well, this is a method that takes self and amount. So if I wanted to call this thing, I would need to pass in both the account that I want to deposit into and the amount, and then the depositing would happen.
I find that really offensive, John. I don't like, this is something I don't like about Python, by the way, is that, you know, the syntax, it lets you do the same thing many, many different ways. And I find that a little confusing.
Yeah, it is confusing. I mean, I think that functions are very fundamental in Python. And classes, yes, they are. But if you look under the hood, like it's actually just built out of things that we already know. So this thing that's like a method is actually really just a function, except for if you have an account instance, then something special happens with that function, meaning self gets filled in. So things are unfamiliar in that kind of everything's new with object-oriented programming, and yet it is built on the stuff that we've already learned. So yeah, the question is like, what can self ever refer to? And self by itself, sorry, self itself is always a name for an object which is an instance of this account class. So what that means is that every time you use self within one of these methods, you're referring to a particular account. Which one? Well, you don't know. That's going to come later, is that somebody's going to build an account and going to start depositing into it. And self will be the name that you use to refer to whatever that thing is that somebody built later. So it's a placeholder, just like you'd always have. within parentheses of a function, like stuff that hasn't been determined yet. But this one is special because it's going to be an account, an object, which is an instance of the account class. Because you know that's true, you know certain things about it, like it was passed as the argument to init, therefore it has a holder and a balance. The next question was, can self only be used to refer to particular attributes, or could it be used to refer to methods as well?
Sure. So if we start writing more methods function, I can, within the class, call one of my own method functions. Yeah. So at the other side, within the class, so we certainly know outside you can call a method function of a class once you have an object. Self is just the object. It's just a special name for an object. So within the class, sure, I can call member functions all day long using self dot and then whatever the function is and pass some parameters. Yeah.
Even within init, you're kind of free to do whatever you want. So this is like a really nice bank. I'm not sure such a bank exists, but
actually, John,
there's a really nice bank. You could deposit into it right away.
Yeah, just go ahead and so say when you open your account, you want to deposit. Well, John's a little stingy, $4.
Right.
And that
we'll do it honey style. Okay. So yeah, go ahead.
Okay, 400, better.
Great question. So is every time we're referring to self dot something and assigning to it, is that a form of mutation? Yes. What we're changing is self, is the account object. So this account is something that's mutable. And instead of like having elements like a list or something like that, it has attributes. Ways that it can change are that it can get brand new attributes. That's what happened here. We gave it a holder attribute that it didn't have before. Or you could update attributes that already exist. This already had a balance, and now the balance is changing. But in either case, we are mutating, which does mean that if we have two names for the same account, and I deposit into A, I have in fact deposited into B as well, because B and A are just names for the same thing, and it's the thing that's changing. It's not the variables that are changing. Okay, good question. I think you're asking about an example where an instance has an attribute with some particular name, like interest, and the class also has an attribute with that particular name, interest. And therefore, if you have an instance and you try to look up the attribute value for interest, you get the instance attribute instead of the class attribute, because that's where Python looks first. So when does this happen? There's two ways to set a class attribute. I could just write it in here. That will be fine. Or I could add it if I have access to the account class. I could give it a class attribute like that. And both of them do the same thing. Okay, so now that the account class has an interest, that means every instance of this class will also have an interest. And so if I make one of these, it has an interest. But this is actually not an instance attribute, it's a class attribute. There's no real way to tell that based on how we used it here. It's just part of Python that it looks in the instance attributes first, and if it doesn't find interest, then it looks in the class. And it happens to have found this one in the class. But if we gave this thing an interest attribute, well, that might be too high. Now, it has changed, but the account's interest rate has not changed because this was instance attribute assignment, which changed an instance attribute. And we didn't change the account. If I made a new account at this point, its interest rate would be whatever the class's one was, because B doesn't have its own instance attribute. And yeah, let me pause there, and then I'll answer your final question. Okay, I think your final question was, is there some way to get A to behave like all the other accounts? Like right now, A has a different interest rate than all the other accounts. Could we make it go back and like use the class instead of the instance? Well, there's a way to get the values to be the same, which would be to write that the instance attribute is the same value as the class attribute. Then they would look the same for now. But if the class changed again for some reason, then A would be out of sync. Oh, sorry, I typed this wrong. Oh my gosh, now I got to go back and do it because of that one typo. Okay, so if account's at 0.3, now A is at 0.3, but if we change the account to 0.4, then A's interest is still 0.3. There's still out of sync. Can you somehow say, like, I don't want A to have its own special instance level interest rate. I want it to just be like all the other accounts. There is a way. I don't typically teach it in this class because it's used so rarely that it's like you could not worry about it, but there is a way, which is that there's like a special keyword called del that would get rid of the instance attribute, at which point A still has an interest, it just happens to be the class's interest. So that's kind of the answer to your question, but this is not something you need to know because I just have never seen it used in the world. And so it's possible, but it's hard for me to imagine a case where you would want it. The next question was about the relationship to Java, which has private and public keywords that don't seem to exist in Python. Is there some equivalent in Python?
Okay, so let me just interject here for those who haven't done Java. Mashan obviously knows a little bit of Java. So a lot of languages have this notion of classes and objects. C++, C#, Java, etc. Not all languages do, by the way. And within Java, for example, there is a notion of a public method and a private method. A public method can be called by anybody, and the private methods can only be called from member functions within the class. John, I actually I don't know if this has changed in Python 3. Is there a notion of public and private in classes in Python 3?
There is, but it's much lighter weight. So in a language like Java, it's really like strictly enforced. In Python, instead, there's a naming convention. It's a weird one. We don't really talk about it in this course, but you'll see it in like industrial code, which is that if you want a method that you don't want anyone else to call, but it just like is there to help, like check that balance is not negative or something like that. Assert that self.balance is greater than or equal to 0. You might want this somewhere, but you don't want other people to call it. The convention is to put one underscore in front of it. And that basically says like, oh, this could change. People shouldn't rely on this. But it's possible to call it anyway. It's just like try not to use it.
Right, but it's not enforced, right, John? I could still call that function.
You can still call that function. It like doesn't show up when you generate the docs and stuff like that. So there is like a little bit of soft enforcement. There is stronger enforcement, which is that if you put 2 underscores, then this is genuinely hard to call because some crazy thing happens with naming that I won't describe. But that is a feature that I think is quite rarely used because it's like hard to understand. So the convention is basically like, if there's stuff that is just like for internal implementation reasons, then you put a little underscore there, and that lets everybody know this is not something that's part of the class, it's just part of the implementation.
That is the very definition of a hack.
It is definitely a hack. Now, you might wonder, like, is Python deeply broken? Well, this idea of private and public came from a time when you wanted to write code that's kind of protected from other bad programmers. And there are settings in which this is a good idea. Like if you're building a library that thousands of people might use and they might, use it wrong, and if using it wrong, like delete somebody's bank account, then it really is important to make sure that it's impossible for them to do it wrong. And this protection system that exists in Java is for that kind of industrial setting. Most of the cases where Python is used, it's more collaborative rather than defensive. Like, you know, you write your class and you tell people how they use it, but they can hack on it and mess around with it if they want to. And as long as all the programmers are friends and they're willing to understand how it works, like that can be perfectly productive too. So it's a different approach to building libraries and building code that interacts with other people's code. Good question. So is there some way to make a user-defined class immutable? This is basically not part of Python as far as I know. There might be some way, but I don't really know what it is. And it doesn't really happen. What does happen sometimes, and we'll learn about this in the next lecture, is that you can specialize some kind of immutable class that already exists. So you can make like a special kind of tuple that behaves slightly differently than a regular tuple. But fundamentally, since tuples are immutable, then this specialization would be too. But other than that, I think the answer is no.
That was I'm not positive, but I don't know of a way of doing it. And by the way, that's not a bad feature. You could certainly imagine wanting to create that type of protection. I just don't know or don't think it exists.
There are, I would say there's certainly lots of open source projects where classes are defined that are meant to be used immutably. Meaning like the design of this thing is that you create it and you don't change it. It's just that the Python language doesn't force you not to change it. So it's really kind of up to you as the user to read the docs and say like, oh, this says and we're not supposed to change it, and then it will work correctly. So let's not change it.
Good. So Raymond is asking a question about what we call selector functions. And I think we've actually talked about this in the class. And so you saw that John in the Python window was directly accessing the balance variable, which you're allowed to do. I think John can disagree with me if he wants to. That's considered bad form. That really you should use functions to access and set the data fields and not access them directly. So it's really all about the abstraction. What's nice about having a function that says, give me the balance is I don't need to know the variable name. And if I change something in the underlying data implementation, which you've heard us talk about before, well, the functions are going to do what the functions do, and I don't have to change my code. So I like when I build classes to have what I call selector functions, which return the balance, return the name. And I like to have functions that set them. And that's the only way I access the data. Now, Python doesn't force that. You can do whatever you want, but I think I like that as sort of a clean implementation so that if I then go back up and change the underlying data representation, I've only got to change a couple of functions, and John's writing them exactly here, these selector and functions.
Yeah, so I mean, there's trade-offs in everything. So a getter and setter, or a selector and I'm not quite sure how they call it.
I don't know what the other one is. Yeah, getter and setter.
But often they're called getters and setters. Yeah. Functions might look like this. And you know, something you might typically see in a Python program is that this will indicate that it's not supposed to be accessed directly with like an underscore or something like that. And the nice thing about this level of indirection is that, yeah, if instead of having a balance, you decide one day you really want like to represent this as something else, you can do that. And the interface that people access this with hasn't changed, which is nice. But you've added, you know, a little bit of code, and you still have the case that like this part can't be changed, or everyone has to change their code. And so
you pushed it upstream a little bit.
Yeah, I think you just got to think. I don't think there's like a perfect general rule. Sometimes this kind of indirection is quite helpful because you're not sure about what your final attributes are going to be. Sometimes it's just kind of extra work because you're pretty sure you're going to have a balance forever and you want people to be able to mess with it. And so like, why have them mess with it with these functions instead of just using it directly? It's just a trade-off, right? You know, how much do you want to future-proof your code to make sure you can change it later. This is one technique to do it. In some settings, it's a good idea. I think that there was like a big push in the education community to tell everybody to do this everywhere all the time because of this disposition I described earlier, that you need to be very defensive of the users of your programming language or users of your library later on. You want to like make sure that they don't use it in the wrong way. And so you want to kind of protect your data and make sure that it's impossible for them to change it. And that disposition is effective in certain like industrial settings, and in other ones it's not. Like if you have a more collaborative group of people all working together, then it can be really nice to be able to kind of dip in below the abstraction and mess with something because the original programmer didn't anticipate exactly how you want to use it, and you want to do some feature that manipulates the balance in a way that they didn't think about. And so you want that like access to stuff that they didn't really think that you were going to access directly. It just depends. So so this is a pattern that we don't like obsess over in this course, because I think that it's fine to think about object-oriented programming as a way of compartmentalizing changing state. So like have the mutation happen on particular objects as opposed to globally, and have objects interact with each other by kind of calling methods on each other. Like that's really the important part. And the protecting against other users, I think, is something you could learn about in another course, or we could talk about it now. It's a fine thing, but I don't think it's the most essential part of object-oriented programming. If you do this kind of all the time with every single attribute that you include, then you could just like generate a lot of code, and it's hard to see kind of what's the meat of this class, because you've got a bunch of other stuff that doesn't really do anything.
Okay, that's nice of you. So Josh has a question. Can you please explain the difference between remove and del methods? I don't actually know the difference.
Yeah, I can. So there's a remove method on certain objects, but not many. So for example, a list. A is a list, an instance of the list class, and there's a remove method on there, which does a particular thing that's list specific. It goes to the list and it removes the first element that's equal to whatever you pass in. Del is something that's really general. It applies to any object, and what it does is it tries to remove an attribute from that object. It actually, I think, doesn't work on a lot of built-in stuff. We'll find out in a second.
It works on lists. It works on, I think you can say del a sub 0.
Oh, that's true. So if I try to get rid of the remove functionality, it will say,
oh, no, right.
This is like built in.
Element.
If I try to, okay, so what is A now? If I del a 0, then that will get rid of the 1. So that's kind of like remove, except for we've picked an index as opposed to a value to remove. But del is actually pretty general. So as you can see, it's not a method. It's not using dot notation, but instead it's its own kind of statement. And you can del from all kinds of stuff. But I basically never use it because I think it's almost always better to just use the methods that are built into the class. So it does exist. Maybe you want it sometimes. Maybe you could never use it and do everything that you want to do. The next question was about explaining parts 10 and 12 of homework 3. All right, homework 3 was all ready to do. And there were some extra questions that you didn't have to do, but I think are interesting. And they were about data abstraction, where we had an abstraction about an interval. And that interval basically described, there's some number, but we don't know what it is. So instead we're saying like, oh, it's between 3 and 7. And that means we know it's in there. We just don't actually know whether it's 4 or 5 or 6. That was the idea behind this question. So if you haven't done it yet, the first part was to build an interval abstraction. I guess we could probably just do that. If you want the lower bound, then you return the interval's element at index 0. If you want the upper bound, then you could return the element at index 1. And that's because we constructed it in this particular way. There was some notion of multiplying. I wonder if we need that for question 10. Probably. Yeah, let's add this notion of multiplying. Oh, it's given to us. Excellent. All we have to do is fix the data abstraction violations, which I think would be that you get the lower bound of x times the lower bound. Oh, this is going to take a while to type. Sorry. We could have the lower bound of x times the upper bound of y. We could have, okay, so let's talk about what's going on here because it's actually really important. When you multiply two numbers together, there's only one answer. But when you multiply two intervals together, basically what you're saying is, I'm multiplying some number and I don't know what it is, but it's in this range, with some other number and I don't know what it is, but it's in this other range. Okay, got rid of the abstraction barrier violations. What would it mean to have an interval from -1 to 1 and another interval from -2 to 2 and multiply them together? It tells me -2 to 2. Why is that? Well, we don't know what the number for A really is. It could be -1 and B could be -2, at which point, if I multiply those two numbers together, I get 2. Well, this was kind of a lousy example. Let's have this go from -2 to 0. Okay, see what happens when we multiply. Okay, so even though like it's not obvious how you get to the number 2, well, the way you get to the number 2 is A is -1 and B is -2, and so you multiply two -2 numbers together and you can get a positive number. How you get to -2, I guess, is maybe A is actually 1. You don't know. It's like somewhere in that interval. And you could multiply that by -2 and you would get -2. It's also possible to get like anything in between. You could get a half because this is 1. Oh, sorry. This is -1 and this is a half. Did I do that right? No. If A were -1 and B were -1/2, then you'd get a half. That's like in that interval somewhere. Okay, finally I got it right. Here's something weird. What happens if you multiply A by A? It says you could get anything from -1 to 1. But I argue this is wrong. Because if you take some number and you multiply it by itself, you never get a negative number. Right? Anything squared is greater than or equal to 0. That's just like a fact. Yet somehow we have code that says if I multiply A by A, I could get anything from -1 to 1. So something has gone wrong. And that was what this question was about. So let's read the question and then try to understand what's going on. So sometimes when intervals are computed by different but algebraically equivalent expressions, you get different results. And the problem is multiple references to the same interval. The multiple reference problem is a formula to compute intervals using this system, the system that has things like mul interval, will produce tighter error bounds if it can be written in such a form that no variable that represents an uncertain number is repeated. Why is it that multiplying A times A, according to this system that we've built, gives you the wrong number? What would the right number be? Well, I think the right number would be if you take some number between -1 and 1 and you multiply it by itself, you can get anything from 0 to 1. But you can't get anything negative. And the reason this gets it wrong is that this code assumes that x and y could be different numbers. But in fact, if these are the same interval, they're really referring to the same number. You don't happen to know what it is, but it can't be different for the x and the y. It couldn't be that some number which is between -1 and 1 is both -1 and 1 at the same time. That's not what intervals are. Intervals are about one number and we don't know what it is. So for that reason, when you write all this code and you think it's going to work, it actually doesn't work correctly because you have an implicit assumption that x and y are different intervals, but in fact, if you pass the same one in, then you're kind of using intervals wrong. That's the story of question 10, multiple reference problem.
Yeah, I haven't seen question 12, which I think was also part of Tan's original question.
After considerable work, Alyssa P., a hacker, delivers her finished system. Several years later, after she's forgotten all about it, she gets a frenzied call. It seems that Lem has noticed that the formula for parallel resistors can be written in two algebraically equivalent ways. Okay, I'm pretty sure this was supposed to come before question 10, but here's two different ways of writing down what should be the same equation, right? Because if you write R1 times R2 divided by R1 plus R2, that's the same thing as writing 1 over R1 plus 1 over R2. Except that this refers to R1 twice, and this only refers to R1 once. So if you use the system that we've built, combining with multiplication and division, R1 and R2, but you've got R1 in there twice, according to the way this multiplication function that we wrote works, you're going to have like a different value for R1 somewhere in that range in one part of the equation than you do in another part of the equation. And that is broken. So I think that the point of this example was that it only works, like this interval computation system that you've built only works if each interval only shows up once. If it ever shows up twice, then you get the wrong answer.
Yeah, I think that's the nugget of it. It's not how I would have interpreted it, by the way, but I think the nugget is that when you have the same interval, you are assuming that you're choosing the same value from that interval, and then the rules change.
Yeah, and so you'd have to write a new system. A follow-up question was whether this has to do with programming or Python, or it's just about this particular interval example. Yes, this has nothing to do with programming, except for you do need to think about what you're representing in the world when you write your program. And here's an example of that. It's like if you just like assume everything's fine, but you forgot that the interval you're representing only can be one number at once, then you might run into trouble. Okay, what's a static method and when would you use it? A static method is just a function. And you would write it like any other function. Like if I want to be able to square a number, I would write that. What if this function was really kind of associated with a class in some way? And so I wanted the way that people access it to not be, what am I doing? To write square 12. I really wanted them to write like math dot square 12. And why would I want it this way? Well, it's basically just a way of saying like, I want to group a bunch of functions together and I want to use a class to do it and have attribute notation kind of take care of that for me. Well, if I make a math class and I put square in there, something's gone wrong because normally methods start with self, but there's like no self. There's not a math out there. This is really just like a different way of using classes to just group stuff together. And if I want square to be a regular function, but happen to exist inside of a class, then there's a decorator to do that. I think it looks like that. And what's the story here? Well, now I can square stuff. If for some reason I made a math, I could square stuff with that math and it wouldn't try to like fill in a self for me. So all this does is get rid of any kind of interesting self behavior and you leave out self entirely, which means that this is reduced to just being a regular function. And so if you didn't want to like have regular functions live inside classes, you wouldn't need this at all. But sometimes organizationally, you want that because you want people to refer to it in a particular way, at which point you might use a static method. The last question was, is there anything you don't like about Python's object system? Good question.
Sorry, I just ended the question. I have 1 minute. Yes, the answer is yes. I don't like how undisciplined it is. There are things I like, which is unlike Java, you can actually write code without classes, and that's nice. It's nice you can just get your hands dirty. I don't like sort of the sloppiness of it that you can it's not quite as precise as I would like. Like for example, Mashan asked about the public-private. I actually think that's John's right. We're not adversarial, but I tend to think that that kind of functionality is nice. But there's other things I really like about it.
Yeah, it's really minimal, and that's not ideal in a lot of settings, especially when you're trying to collaborate on like really large programs across many people. I think the minimalist flavor of Python's object system kind of limits the ability to scale this to really large programs. Now, people have done it anyway, but they've often done it by building a lot of extra infrastructure on top of the language. Like you come up with some system for defining who is allowed to call what that isn't built into the language. And that's just a shame, right? It's better to have it kind of built in. But it's a reasonable decision. It's just a compromise. Like having something that's simple can be good because then people can learn it faster. And when you read somebody else's code, you're not faced with a bunch of like tricky stuff that you've never heard of. At the same time, it can be a barrier to like really using the language for something extremely ambitious. So like I was at Google for a while and there was a lot of Python code, but there were rules about how you were allowed to write your Python code and like extra comments that you had to put everywhere that were pretty elaborate in order to basically force some kind of additional structure into the language that wasn't there. And that seems like indication that the language was not a good fit for how it was being used. And yeah,